Hey guys, welcome back to my channel. Yes, today I'm going to test this cell phone signal booster. I have spotty coverage in my home basement, so thought of trying this PhoneTone signal booster. Most YouTube videos talk of the installation. Installation is straightforward. At this time I don't see anyone doing the actual gain test. So here is the test, and this is just out of academic interest in the context of amateur radio, and it is not to prove anything or disprove anything, nor to endorse anything. And the antenna gain is not accounted for. These are the contents in the box. Indoor directional antenna 120 degrees, the actual booster, outdoor omnidirectional antenna, RG58 coax cables, and mounting accessories. This is a simple gain test on the PhoneTone cellular booster, and it has provision for LTE, Cell, PCS, and AWS. So accordingly, I'll be using marker 1 for LTE, marker 2, marker 3, and marker 4 respectively. And I'm using the outdoor port as the input port. Since this is duplex, I'm just testing in one direction for this video, and I'm using the indoor port as the output port. Although I have used an input attenuator, at the moment there is no attenuation. I have removed all the attenuation, as you can see here, and that is connected to the input port here, which is the outdoor port on the PhoneTone cellular signal booster. And likewise, I'm using an attenuator here, but this has a 20 dB attenuation connected to the output port before it goes to the network analyzer. And these are the standard cables supplied along with this unit. So I just wanted that to be in the picture. There's only one extension cable which is not present here, which I have not used. Otherwise, these two are the RG58 coax cables that came with the unit. And as you can see, the gain for all the 4 bands is set to max on this unit. And for this test, I'll be using my HP8753A network analyzer along with the 85046A S parameter test set. I have now introduced 30 dB attenuation at the input side. So we have the 20 dB in, 2 dB and 8 dB, so that makes it 30 dB attenuation. The output attenuation remains at 20 dB, that's the output, and we have the 20 dB pressed in. This is the LTE band, and I have centered the frequency at 744.03 MHz, and as you can see, the gain is -2 dB, and I'm scanning from 700 MHz right up to 800 MHz here. Now here is the cell band, and I'm scanning from 820 MHz right up to 910 MHz, and I have centered the frequency at 880.5 MHz, and the gain is -16 dB. This is the PCS band, and I'm scanning from 1.9 GHz right up to 2.05 GHz here. And I have set the marker at 1.96 GHz, and the gain is -13 dB. This is the AWS band. I'm scanning from 2.05 GHz and stopping at 2.2 GHz, and set the marker at 2.136 GHz, as you can see here, and the gain, indicated gain, is -10 dB. In conclusion, you can see that the overall gain is as follows: LTE 47.22 dB, Cell 33.21 dB, PCS 36.55 dB, AWS 39.5 dB. Thanks for watching.